Hello everybody, today we will start our revision for Applied Mathematics for grade 11, second term, starting by showing some rules in our content. Firstly, the unit measure of speed. Speed have a many units of measuring like kilometer per hour and meter per second and centimeter per second. Kilometer per hour, meter per second, and centimeter per second. To convert from the different units, firstly, if I have kilometer per hour and wanted to convert it to meter per second, I will multiply it by 5/18. If I want to convert from kilometer per hour to centimeter per second, multiplied by 250/9, and the vice versa. Like if I have meter per second and I wanted to convert it to kilometer per hour, multiplied by 18/5, and convert from centimeter per second to kilometer per hour, multiplied by 9/250. Make a reciprocal of the two fractions. Okay. Average speed and average velocity. What is the difference between them? Average speed equal total distance over total time, depended on distance, but average velocity equal total displacement over total time, depended on the displacement. Okay, what is the difference between distance and displacement? Look, if the body is moving from point A to point B in the direction of east, 4 units, and then moving from B to C, 3 units, to a north direction, then the distance here, the distance makes with the body, okay, like 4 units and 3 units equals 7 units. But the displacement is distance from the starting point to end point. This distance between first point and last point. Okay, here from Pythagoras I can find length of AC equal root 3/2 plus 4/2 equal to 5 units. Then distance is 7 units, but displacement is 5 units. Okay, that's a difference between distance and displacement. And here make a difference between average speed and average velocity. Average speed depended on distance, but average velocity depended on displacement. Why? Because speed is a scalar vector like distance, but velocity is a vector quantity like displacement. Okay. Okay. The relative velocity. Relative velocity means velocity of the body with respect to another body. It's different about the actually velocity of the body. Okay, that means velocity of A, B means velocity of body A with respect to B. With respect to B. And that's different. That's different about the actual velocity of A. It's not actual velocity of A. Like the two bodies A and B, مثلا velocity of A equal 20 meter per second, and velocity of body B is 13 meter per second. I want to find the velocity of VAB. Okay, if the two bodies are moving in the same direction, then they have a same sign, 20 and 30. Okay, then 20 minus 13, 20 minus 13 equals 7 meter per second. That's a relative velocity. That's different about velocity of A and velocity of B. That's velocity of A with respect to B. Okay, if I want a velocity of B with respect to A, then I will subtract velocity of B first minus velocity of A. It will be -7. Okay, and it's negative because body B is slower than body A. okay? But if the two bodies moves in opposite direction, then the two bodies have a different sign of velocity. يعني if velocity of A equal 20, then velocity of B negative 13. Negative 13. If I want to find velocity of AB equal 20 minus negative 13, velocity of AB, it will be 20 minus negative 13. It means 20 plus 13. 33. Why? Because they are in opposite direction. Then they have a different sign. Okay, that's a relative velocity, of the body with respect to another one. Here, the three rules of motion. First one is V equal V naught plus AT. V refers to the velocity. V naught refers to the initial velocity. Initial velocity means velocity of the body at beginning motion. Okay. A is accelerate of the body. Okay. Maybe positive, maybe negative, maybe refers to accelerate or decelerate. Okay. Number T is a time. Okay. Here, second rule equal S equal V naught T plus half AT square. V naught and T and A, I said it before, but S is a new symbol, is refers to distance. Here is equal V naught T plus half AT square. Three rules, I can use them to find any unknown, like distance, velocity, initial velocity, accelerate, time, when body moving horizontally. Okay? If the body moving horizontally, but with uniform velocity, I didn't use any one of them. I use this formula. Distance, velocity, and time. Distance equal velocity multiply time, and velocity equal distance over time, and time equal distance over velocity. I use this when body moves with uniform velocity, no accelerate. When accelerate is equal to 0, I can use this one. Okay? But if I have any accelerate or decelerate in the body and moving horizontal, I use one of them. If the body moving vertically, not horizontally, here that's horizontally, dependent on accelerate. Accelerate when the body moving horizontally. If the body moving vertically, I use another one. I will talk about it after some moment. Okay, here I have some remarks. Number one, the previous equation, these three equations we talk about, connect between four unknown values. We can get one of them if we know the values of another three of them. rules عندنا, if I have many rules and I want to find one of them, I can use any equation to find it. Number two, the sign of each V and V node determined according to the direction of unit vector. Okay, the starting motion and end motion. We said V is a velocity, but V naught is the initial velocity, and A is the accelerate. At the beginning of motion must be time equal to 0. That's logic. If the body starts its motion from the rest, he said in example, body start its motion from the rest, then V naught equal to 0. If the particle reaches to the maximum height, okay, the point of maximum height, at this point, velocity, it will be 0. At maximum distance or maximum height, the velocity must be equal 0. If a particle moves with uniform velocity, then no accelerate here. Also at maximum velocity, not maximum height, okay, maximum velocity, accelerate equal to 0. A particle returning back to the start point, the initial position, then displacement equals 0. If I return back to the first point, then no displacement here. Here I have a distance, but not displacement, because the start point and last point, they are same. Okay? And then number 8, if the particle returns back to the start point يبقى initial velocity يبقى s equal to 0. In the case of knowing the values v node, v, and t, it's not necessary to get a to find the displacement. I can use this rule, v node plus v over 2 multiplied by t. Okay. I have another remarks. It's important to find the distance which is a particle covered within n seconds. We should find the distance which it covered within the first n seconds and the distance which it covered within the first n minus 1 seconds. What does it mean? If I want the distance at instant moment, like مثلا a third second, I want to find a distance in third second. How can I find it? I must find distance at all the 3 times minus distance at 2 seconds. Okay, يبقى distance at 3 seconds minus distance at 2 seconds. Okay, يبقى first 3 here, that's a 0, 1, 2, 3. Distance of all these moments, okay, minus this. يبقى this the distance at third second. Okay, in general, I can set that distance of the big one minus distance of previous of a smaller. Okay, distance of a big time minus distance at the previous of a smaller. Previous of a smaller, it's mean before of the smaller one. Okay, here I have third, 3 minus 2. If I want fifths and sixes, then equal S6 is the biggest one minus distance at previous of a smaller, before the smaller. Smaller here is 5. The number before 5 is 4. Okay, again, if I want the distance at 8s, 9s, and 10s second, okay, then I find distance at a biggest one is 10 minus distance before of the smaller. Smaller here is 8. Before 8, it's 7. يبقى distance at 10 minus distance at 7. Okay, here, the laws of motion bodies. I said V equal V node plus A T and V square equal V node square plus 2A S. S equal V node T plus half AT square. This is three equations of motion horizontal. If I'm moving vertical, then I will replace A and put G. Replace A by G. Here, since the body which are moving vertically freely have a uniform accelerate whose magnitude is G. G is called the gravity. Then we can apply the same laws of motion, نفس rules of the motion on the straight line by replacing the symbol A by G. يعني no accelerate here, but I have a gravity, okay? And the gravity have a constant value, not variable like accelerate. No, it's constant. G equal 9.8 meter per second square. Okay, then gravity is have an equal and constant, have a constant value 9.8 meter per second, but accelerate have a variable values. Okay, I can replace a symbol A by G. No A here, it will equal to G. V equal V node plus GT and S equal V node T plus half GT square, not AT square. V square equal V node square plus 2GS, not 2AS. These rules using in horizontal motion, these rules using in vertical motion. Okay. The last thing here, finding the time and distance of the maximum height projected vertically upward. If I catch a body and project it vertically upward to reach to the maximum height. What is the time taken to reach to maximum height, and what is the maximum height? At maximum height, in general, at maximum height, V equal to 0. Then I can use this rule. Time to reach to maximum height equal V naught over G, the initial velocity over the gravity. Gravity is 9.8, is a constant value, okay? Don't forget. To find a maximum height, V naught square over 2G. Initial velocity square of initial velocity over 2 times gravity, rate 2 times 9.8. Okay. Lesson 4 is cancelled for this year. For this, we didn't talk about it. We're starting to solve some questions on our content. A body is projected vertically upward with a speed 19.6 meter per second. Then the time to reach to maximum height equal what? That's the last point we talk about is. That's a speed projected by this speed. Then it's refers to 19 initial velocity, 19.6 meter per second. Time to reach to maximum height. Time equal V naught over G. Okay, V naught is 19.6 divided by gravity is 9.8. It's a constant value, not a change. The result, it will be 2 seconds. 2 seconds, okay? That's the answer. Next one. From the top of hell, 9.8 meter high, a stone is projected vertically upward with a speed 4.9 meter per second. Then the velocity of the body at the moment of reaching the ground surface equal what? Here the gravity is 9.8. Okay, and I have a distance 9.8 meter. Here gravity is meter per second square. Okay, the unit. Okay, the node, the initial velocity is 4.9 meter per second. Then I can use the rule. I wanted to find the velocity. V square equal V node square plus 2gs equal V node square is 4.9 power 2 plus 2 multiplying gravity 9.8 multiply the distance is 9.8. Okay, and then I want to find the V. It's a root of the value I have. It will be 14.7. This expression refers to V square, but I want V, not V square. Then make a root for the answer. It will be 14.7 meter per second. Okay, next. Two cars, A and B, are moving on a straight road in opposite direction. Opposite direction means they have a different sign. Their velocities. Their velocities have different sign. With the speed 125 km per hour and 75 km per hour respectively. That means a first body is 125 km per hour, but a second one is a negative 75 km per hour. Why I put a negative sign? Because they are in opposite direction. They are in opposite direction. Then make a negative 75. Then velocity of B with respect to A. He said velocity of B with respect to A. Here I want the velocity of B with respect to A, then I will put negative sign at A. I will put negative sign at A because I want a relative velocity of B with respect to A. If I want the relative velocity of A with respect to B, I will put negative sign at B, okay? VB minus VA, 75 minus negative 125, it will be 200 kilometer per hour. Okay, but the answer I wanted by meter per second. How I can convert? We said before, multiplied by 5 over 18, right? Multiplied by 5 over 18. It will be 500 over 9. Okay. Next one. A particle moving such that its position vector is given by r equals 3t plus 2 in direction of I plus 4t minus 1 in direction of j. Then the magnitude of the displacement tell t equal 2 equal what? Firstly, I want to find the displacement and then substitute by 2. Okay? Displacement equal what? Displacement equal a position vector minus initial position vector. A position vector minus initial position vector. Position vector in example is 3t plus 2 in I direction and 4t minus 1 on j direction. First projection and the second projection minus r node. How can I find r node? R node is the same of r, but when I put t equal to 0. R node is r at t equals 0. Okay, put here t equal to 0, time equal to 0, 3t, t equal to 0, then a first projection is 2, and here put t equals 0, it will be negative 1. A second projection is 1, negative 1, okay? Then displacement equal, make a difference here, 3t plus 2 minus 2. It will be 3t. And 4t minus 1 minus negative 1, it will be 4t. Okay, negative 1 minus minus, it means plus, negative 1 plus 1 cancelled, then the difference is 4t. Okay, distance at time equal to, put t equal to 3 times 2, it will be 6, and 4 times 2, it will be 8. That's a vector of displacement. I want a magnitude. I want a magnitude of displacement, not a vector. How can I find the magnitude? Root a first projection square plus a second projection square equal 10 length unit. Result is 10 length unit. And next one. A body is projected vertically upward with a speed 40 meters per second from the top of the tower 90 meters high above the ground surface. Then the time taken to reach to the ground. Come on. Here I have body projected vertically upward by this speed. Then that refers to V node. V node equal 40 meters per second from the top of the tower, 90 meters high. The distance is 90 meters high. I want time taken to reach to the ground. Firstly, that's a tower and that's a ground. Here is 90 meters. A body is projected from here, from the top, by this speed to reach to the maximum height and return back to the ground. Okay? Firstly, I want to find the time to reach to maximum height and return back to projection point and then return back to the ground. I have 3 stages. Okay? Stage number 1, time to reach to maximum height. Time to reach to maximum height. V node over G. V node is 40 and gravity is 9.8. 40 over 9.8, it will be 4.08 seconds. Okay, approximately 4.08 seconds. To back to the projection point, to return back to the projection point, I take at same time again. يبقى time to return to projection point equal 4.08 second also. يبقى that's a first time, that's a second time. Firstly, the time taken to reach to maximum height, and then time taken to return to the projection point again. The last time to return from this point, projection point, to the ground. Okay. In this case, I will use the distance 90. Here I have rule distance equal V naught T plus half AT square. Distance is 90 meter, V naught 40. I don't know the time, I want to find it, plus half multiply, here not a G, that's a G, not A, okay? Half GT square, 9.8 times T square. It will be an equation in a second degree, 4.9 T square plus 40 T minus 90 equal to 0. The time have two values. One of them is 1.84 seconds, and another one is a negative. It's refused. No time by negative sign. Okay, then that's a third time. That's a third time. يبقى time to reach to the ground, it will be what? 4.08 for a first stage and 4.08 again to return to the projection point, and then 1.84 to go to the or return to the ground. Total of time is 10 seconds. Total of the times is 10 seconds. يبقى time of the whole journey. Journey have three parts or three stages. Firstly, time to reach to maximum height, and then to return back to the projection point, and then time to reach to the ground. Okay, and it's three stages. Then the total time is 10 seconds. Next one, a motorcycle moves with the speed 25 kilometers per hour. If the rider observes a car moving in opposite direction, that means they have a different sign. Okay, their velocities have a different sign. It seems to him the car speed is 105. That's not actually speed of it. It seems look like to him. Okay, then the actual speed of the car equal what? I will name a velocity of motorcycle VM equal 25 kilometer per hour, but here I want meter per second. Then I will convert it, okay? Or I can convert it in the last. Here I have kilometer per hour and here kilometer per hour. Okay, I can find the actual speed of the car and then convert to meter per second. Okay, don't forget the conversion in the last step. Velocity of the car with respect to motorcycle. Velocity of the car with respect to motorcycle is 105. Okay. VCM, the velocity of car with respect to motorcycle, equal VC minus VM. Here, 105 equal. Velocity of car, I don't know. Velocity of motorcycle in opposite direction, then it will be a negative 25. Okay. Then velocity of the car equal 105 minus 25 equal 80 kilometer per hour. I want to convert to meter per second multiplied by 5 over 18. Multiplied by 5 over 18, it will be 200 over 9. 200 over 9 meter per second. This is the answer. Next, the car velocity is reduced regularly from 66 meter per second to 79.2 kilometer per hour. There have a different sign, different units. Firstly, I must convert, okay? 79.2 kilometer per hour multiplied by 5 over 18, it will be 22 meter per second. Okay, then the velocity of the car is reduced from 66 to 22 meter per second. Okay, the velocity is decreasing and a cover distance is 66 meters. Then the further distance covered by the car till it comes to rest. From this first motion, I can find the accelerate. and then use it to find the distance. Okay, I have a rule, v square equal v node square plus 2as. The terminal velocity here is 22 square equal the initial velocity 66 square plus 2 multiplies the distance is 66 multiplied by a. I want to find the accelerate. By the way, accelerate here it will be negative because the velocity is decreasing. Then accelerate is negative. Accelerate equal 22 square minus 66 square over 2 multiplied by 66. The answer, it will be negative 29.3 meter per second square. Here, I find the accelerate. I can find the distance to reach to rest. I have a rule. I said that if a new motion, V node is 22, the last one here, I will start by it in the second motion to reach to 0. Okay, V node, it will be 22 meter per second, and at terminal 0, it will be a terminal velocity, it will be 0, and the accelerate is negative 29.3. I want to find the distance. Then rule V square equal V node square plus 2as. V square is 0 equal V node square is 22 square. 2 multiplied by negative 29.3 multiplies the distance. To find the distance, negative 22 power 2 over 2 multiply negative 29.3. The distance is, by using calculator, the distance is 8.25 meter. That's a distance to reach to the rest by this accelerate. Okay, next example. If a car moves with a uniform velocity of magnitude 90 km per hour for 30 minutes, then cover distance during the period of time measured by kilometer equal what? Car move with this uniform velocity of magnitude 90 km per hour for 30 minutes. Okay, here the velocity is 90 kilometer per hour. He moving by this velocity for 30 minutes. 30 minutes, I wanted to convert it to hours because he want the distance by kilometer. Divided by 60, it will be half hour. Then the distance, it's a uniform velocity. Then I didn't use the rules of motion, but I can use this formula. Distance, velocity, time. I want to find the distance, then multiply velocity by time. Velocity multiplied by time is 90 multiplied by half, equal 45. Okay, next. A car moves in a straight line. It covers a distance 360 kilometers in 240 minutes. Then it covered 120 kilometers in the same direction during 60 minutes. Then its average speed equal what? I want to find the average speed here. First, the distance, average speed equal total distance over total time. Average speed equal total distance over total time. Total distance is 360 kilometer and 120 kilometer. What is the time? The time here, 360 kilometer in 240 minutes. I want it in hours, 240 minutes divided by 60 to convert it to hours, it will be 4 hours and 120 kilometers in the same direction in 60 minutes. 60 minutes divided by 60 to convert to hours, it will be 1 hour. Then total time is 4 hours and 1 hours. 360 plus 120 over 4 plus 5, 480 over 5. 480 over 5, it will be 96 kilometers per hour. The result, it will be 96. Okay, next. The average velocity of a body starts its motion with initial velocity v naught and uniform accelerate during 6 seconds. 6 seconds. We said 6 seconds is distance at x minus s of 5. Here, that's a distance, but I want average velocity. Okay, I know velocity equal v naught plus at. V equal velocity I wanted to find, v naught plus accelerate is a constant, but time at 6 is time. We said that 6 is time start from S5 and end at S6 between them. Okay, what is the average time here? Average time between 5 and 6. To find the average time, I will adding 5 and 6 and divide it by 2. Divide their sum by 2 to find the average time between them. 5 plus 6 is 11 divided by 2, it will be 5.5. يبقى v node plus 5.5 of accelerate. Number C. Next. A bicycle moves with a velocity 4 meters per second toward east for 60 seconds. Okay, then it is stopped for 10 seconds. Later, it moves with velocity 5 meters per second toward west for 30 seconds. Then the average speed. Average speed equal total distance over total time. What is the distance here? First, the first motion is 4 meters per second till 30 seconds. Then the distance, velocity multiplied by time. Velocity multiplied by time is 240 meters to east direction. It's a first distance. A second distance, velocity by this velocity toward west. Okay, it's not important here. I find a distance. Direction is not important. But if I talk about average velocity, the direction is very important. Okay, but here it's a speed and dependent on distance, direction is not important. Okay, 5 multiplied by 30, velocity multiplied by time to find the distance, it will be 150 meters. Direction west, but it is not important here. Okay, time, total time. First motion in 60 seconds and second motion in 30 seconds, but don't forget we have a 10 seconds motion of stopped between the two motions. Don't forget it. It's important. Okay, then the total time is 100 seconds. Average speed equal total distance 240 and 150 divided by 100 equals 390 divided by 100. It will be 3.9. The last answer. Next one. From the top of hill, 9.8 meter high, a stone is projected vertically up with a speed 4.9 meter per second. Find the velocity of the body at the moment of reaching the ground surface. Okay. Firstly, the initial velocity is 4.9 meter per second and distance is 9.8 meter. Gravity, I know it's equal to 9.8 meter per second square. I want the velocity of the body in the moment to reach ground surface. I have a rule, v square equal v naught square plus 2gs equal 4.9 square plus 2 multiply gravity is 9.8 multiply distance 9.8 also equal a value, but I want a velocity. I will make a root of this value. The result, it will be 14.7 meter per second. Okay, that's a terminal velocity when the body reaching to the ground surface. Next one, a particle moved from rest. From rest means V node equal to 0 in a straight line with a uniform acceleration. Okay, it covered a distance 38 centimeter within the 10th second. That means distance 10 seconds minus distance the previously 9, it will be 38. That's a first rule. Find the magnitude of acceleration, okay, and the distance which covered in 50 seconds. I want distance at 50 seconds means S5 minus S4 before 1, okay, equal what? I have two unknowns. Okay, firstly, I want to find accelerate. S10 minus S9 equal 38. That's an equation. I will use it to find the accelerate. S10, I know the rule of distance. We said here, V naught T plus half AT square. V naught equal to 0, then this part I will cancel it. It's not important to me. V naught equal 0. Okay, I will depend it on half AT equal square. Half A, I don't know the value of A, multiply time. Here time is 10 square. Minus distance at 9 is half multiply A multiply 9 power 2. All of this equal 38. First, 1 half 10 square, it will be 50A minus half 9 square is 40.5A equal 38. 50 minus 40.5, it will be 9.5A equal 38. Then the accelerate equal 4 meter per second. 38 divided 9.8, it will be 4 meter per second. I find the first unknown or first required, accelerate. Then I want to find S5 minus S4. Equal what? S5 minus S4 equal. Depended on half AT also, half AT square, half multiply accelerate, I find it equal 4, multiply 5 square, minus half multiply 4 square. The first bracket equal to 50 minus a second bracket is 32. The difference between them is 18 meter. يبقى I find the two required in this example. Next one, a plane moves with velocity 300 kilometer per hour due to the south for 2 hours. Then with velocity 250 kilometer per hour due to the north for a distance 750 kilometer. Then average speed depended on distance. Then the direction is not important. Okay. Here, velocity and time. I want a distance. Distance 1, velocity multiplied by time. Velocity multiplied by 2 hours, 600 kilometers. And then distance 2, 250 multiplied by this velocity is inverse for distance by this velocity for a distance 750. Okay, that's a distance. And here I have a distance. Moment. 250 kilometers not multiplied by anything. Wait a moment. Here I have a second distance. Distance is 750 kilometers. Okay. The time of the two journeys. A first journey, its time is 2 hours. Second journey, its time is unknown. I will divide the distance by the time to find the time. A distance divided by velocity, 750 divided by velocity, 250, equal 3 hours. Average speed equal total distance, 600 plus 750, over total time, 2 plus 3, equal here 1,350 over 5. The division of them is 270 kilometer per hour. That's average speed. Next one, a body is projected vertically upward with a speed v naught to reach to maximum height s. Then the speed should be used to make the body reaches to maximum height is 2s. A body projected vertically upward with a speed v naught to reach to maximum height s. Then the speed should be used to make the body reaches to maximum height 2s. Okay. I know speed, distance of maximum height is v naught square over 2g. What is the values of this initial velocity? Make s, it will be 2s. We can try the rule. First, number A. If I put v naught equal twice v naught, 2 v naught to the power 2 over 2g equal what? Equal 4 v naught square over 2g. It will be 4s, not 2s. Here I know v naught square over 2g, that's is s. Multiplied by 4, it will be 4s, not 2s. Then that's a wrong answer. Next one, if I put v naught equal v naught, then equal s, no changes. Number C. If I put v naught equal root 2 v naught, then root 2 v naught to the power 2 over 2g. Root 2 square, it will be 2 v naught square over 2g. This expression equal to s, then equal to s. That's a right answer because it's equal to s. Next, A and B are two bodies start their motion on the same straight line in the opposite direction. Okay? The first body with a speed 15 km per hour and the other with a speed 25 km per hour. If they met after half an hour, then the distance between them when they start to move equal how many kilometers? The initial distance between them equal what? Here, the total distance equal velocity of car A multiplied by time and velocity of car B multiplied by time. Why? That's A and this is B. The distance between them, it is total distance. A car 1 moved by velocity 15 km per hour, half an hour, and the next one, the other one, moves by velocity 25. Here is 15, and here is 25 km per hour, the velocity, okay? What is the total distance? The two cars met after half an hour. Then, if I multiplied a velocity of car A multiplied by half, I will find the distance covered by car A. And if I multiplied a velocity of car B multiplied half an hour, I will find the covered distance by car B. Add of them is the total distance between the two cars. Okay? Here, 7.5 and 25 multiplied by half is 12.5. Their sum is 20 kilometers. The distance between them is 20 kilometers. Next one, a body starts its motion from rest. That's mean V naught equal to 0. With the uniform accelerate 40 centimeter per second square, that means accelerate equal 40 centimeter per second square. Then its speed after covering 320 centimeter. After distance 320 centimeter. What is the speed after this? What is the velocity after this? V equal V node, V square equal V node square plus 2AS. V square, I want it. V node square is equal to 0 plus 2 multiplied by accelerate, multiply the distance, is equal to 25,600. Then velocity is a root of this number equal to 160 centimeter per second. Okay, that's the answer, number one, number A. And the next one, a body move in a fixed direction with an initial speed and uniform accelerate. Okay, the body covered 20 meter in the third second. Yep. S3 minus S2 equal 20 meter. And then cover 60 meter in the fifth and sixth second. That's mean distance of the biggest one minus distance of the before of the smaller. Smaller is 5, before it is 4, equal 60. Find the initial speed. Okay, the V naught. I want to find V naught. S3 equal what? I know the rule is equal V naught T plus half AT square. V naught T, T here is 3 V naught plus half AT square. T square here is 9, 4.5A minus 2. Substitute T by 2. 2 V naught plus 2 square 4, 2A equal 20. The difference here is V naught plus 2.5A equal 20. That's the first equation. By a second rule, here a second equation I have is 6 minus S4 equal to 60. S6 is 6V naught plus 18A اللي هي half 80 square. T square is 6 square, 36. Half of 36 is 18A minus. By the same is 4V naught plus half 80 square. T square is 16. 16 multiplied by half is 8A equal 60. Then the difference here, 2 V naught plus 10A equal 60. That's a second one. I have two equations and I can find their solution together. V naught equal 10 meter per second. By the way, and the accelerate equal 4. It is not required here, but when we solve the two equations, we find the values of the two unknowns, V naught and accelerate. I want to find the initial speed is V naught is 10 meter per second. Next example. A tennis ball is projected upward to reach maximum height. Its return to the racket after it covered distance 9 meters. From the moment it was projected, then the displacement equal what? Okay, the body is returned to the point of projection again. Then the distance, I can find the distance, but displacement here is 0. Displacement is 0. Why? Because body is returned back to the point of projection. Body move in this direction and then return back. Then no displacement here. No displacement here because the point of start motion is the same with the point of end of the motion. Okay, next one. A ball is projected vertically upward. It takes it takes 3 seconds to reach maximum height. Then the time when the body was 39.2 meters above the point of projection equal what? Here I have a velocity initial. A time is 3.3 seconds, time is 3 seconds, and I can find the initial velocity. Like I can use this rule, 3 equal V naught over G. Okay, the time to reach to maximum height equal V naught over G. G is 9.8, the value of gravity. Then V naught, I can multiply 9.8 multiplied by 3, it will be 29.4 meter per second. That's the initial velocity of the body. Okay, then the time when the body was 39 meter, I want to find it. That's a distance. I have a distance equal 39.2. I have a rule S equal V naught T plus half A T square. 39.2 equal V naught is 29.4 T plus, here I have a gravity, okay, half. Gravity here, body is returning back, okay, then I will put gravity is negative 9.8 multiplied by T square. I have equation in second degree for negative 4.9 T square plus 29.4 T minus 39.2 equal to 0. Time have two values, 2 and 4. Then I will take the 2 times. If one of them is negative, I will refuse it. But here the 2 values can be a time. Then I choose both of them. A particle move from rest, that means V naught equal to 0 in a straight line with uniform accelerate. It covered during 5th, 6th, and 7th. That's mean S of 7 minus S of small, before of the small, 4. Okay, S7 minus S4 equal 132. Find accelerate and distance covered with from beginning of motion till velocity becomes 66. Okay, firstly, I will find the accelerate. Okay, here S7 is V naught is 0, then I will depend it on half AT square. Half multiplied by A multiplied by 7 square minus half multiplied by A multiplied by 4 square equal 132. Half 7 square is 24.5A minus half of 4 square is 8A, okay, equal 132. Then I can find the value of A, it will be 8 meter per second square, okay. I want to find the distance covered till the velocity becomes 66. I have V naught equal to 0, and the last terminal velocity is 66 centimeter per second. Here is centimeter per second, not meter, okay? Centimeter, because the unit is centimeter. Accelerate is 8 centimeter per second square. Then the velocity V naught V square equal V naught square plus 2AS. V square is 66 square equal V naught square is 0 square, okay? 2 multiplied by 8 multiplied by S. Then the distance, it will be, we can use a calculator to find it. Okay, 66 square divided by 2 multiply 8. I can make divided by 16. It will be 272.25 centimeter. Okay, next one. The opposite graph represents the relation between displacement and time to a particle move in the straight line. Then the average velocity. Average velocity, it depended on the displacement. What is the displacement here? Displacement, all of the distance, it will be displacement here, this point, it will be 35. And over total time is 10. Then average velocity total displacement is 35 over total time is 10. It will be 3.5 meter per second. Okay, next one. If a body moves with acceleration A and V over V node minus V node over V equal to 1, then S equal which one here? Okay, by this equation I have V equal V node minus V node over V equal to 1. Make simplify for this fraction, multiply the two denominators and make a cross in numerator. V square minus V node square equal to 1. Okay, here I have rule V square equal V node square minus 2 plus 2as. V node square could go to the other side by a negative sign. It will be V square minus V node square equal to as. Then V square minus V node square equal to as. I will put here, replace the numerator and put 2as. V square minus V node square. I will replace it and put 2as. They are equal. Over V node equal 1. Make a cross multiplication, then 2as equal V node. I want S here. I want the value of S. Then 2a go to the other side by division. Then S equal V node over 2a. Okay, that's a value of S here, number C. V node over 2a. Next one. Which of the following is false? Here I have a four relation. 3 of them is right, but 1 is false. I want to find it. I will try a first one, 90 kilometer to convert to meter per second. I will multiply it by 5 over 18. Number A, 90 multiplied by 5 over 18. It will be 25. Then it's right. It's right. I search for false one. Number B, 20 meter per minute. I want to convert it into a centimeter per second. 20 multiplied by meter to be centimeter, it will be 100 over minute to be second multiplied by 60. It will be 100 over 3. That's right also. That's not a false one. Number C, 20. I want to convert it to kilometer per hour multiplied by 18 over 5. It will be 72. That's right one also. The last one, that's number B. Number D, 45 kilometer per minute to convert to centimeter per second multiplied by kilometer to be centimeter multiplied by 100,000 over from minute to second multiplied by 60. The result, it will be 75,000, not 750. That's a false one. Okay, I search for the false here. A moving radar car to monitor the velocity of the velocity on the desert road. Okay, move with constant velocity 40 kilometers per hour. That's the velocity of the car. This car observe the movement of a truck coming in the opposite direction. Okay, they're in opposite direction. Okay, it seems like it's moving with velocity 120. Then the velocity of a car is 40 kilometers per hour, and velocity of truck with respect to car, it will be 120. They are in opposite direction. I know velocity of truck with respect to car equal velocity of truck minus velocity of car. Here equal 120 equal velocity of truck. I don't know what is its actual velocity minus velocity of a car. Car is 40, but in opposite direction, it will be minus of negative 40 because they are in opposite direction. Then velocity of truck equal 120 minus 40, it will be 80. 80 kilometers per hour. Next example, a car covered 6 kilometers toward west, then it moved afterward 8 kilometers in the direction 60 degrees south of the west. Okay, I will draw the direction. Okay, car moved in west direction here, 6 kilometers, and then 8 kilometers in 60 south of west. South of west like this. Okay, here 6 kilometers in west, and then 60 south of west. That one is 60 here. 8 kilometers. Okay, this angle is 60, then this angle is 120. I want to find the displacement. Displacement means the distance from the beginning of motion to the end of motion. This line, the yellow line. Okay, I want to find this line. How can I find it? I have this is 6 kilometers and this 8 kilometers. How can I find this one? I can find it by using cosine rule. We take it in the previous term, in the first term. Okay? Cosine rule. If I named it O, A, B, I want to find the length of OB. Cosine rule said that OB square equal OA square plus AB square minus 2OA multiplied by AB cosine of angle OAB. Cosine rule, okay? OB square equal. OA square is 6 power 2 plus 8 power 2 minus 2 multiplied by 6 multiplied by 8 cosine of 120 degree. I want to find OB. I will make root of this value. It will be 2 root 37. 2 root 37. Okay? Next one. The time in hours. Wait a moment. Clear? Yeah. The time in hours. Okay, I want to find the time in hours taken by the car moves with a uniform speed 20 meters per second to cover a distance 180 kilometers. Okay, firstly, I must convert 20 meters per second to be kilometer per hour. Multiplied by 18 over 5 to be kilometer per hour. It will be 72 kilometer per hour. Uniform speed, that's mean no acceleration here. Then to find time, I can divide the distance by velocity. Distance is 180 divided by velocity 72. It will be 5 over 2. Its mean is 2.5. That's the answer. 2.5 hour. Okay. Next. In the opposite figure, represent velocity time curve of body start its motion with initial velocity 10 and speed stopped after 110 seconds. Number A, the 3 accelerate of the body. This body have 3 motions. The first one have an accelerate here and then a uniform motion and then decelerate one. I want to find the accelerate in the 3 stages of the motion. First stage, first accelerate here is the slope of this line. Slope of this line, that's A1. Slope of this line equal, which equal the difference between y coordinates over difference between x coordinates. In this case, this point is 0 and 10. This point is 30 and 70. This point is 90 and 70. And the last point is 110 and 0. Okay? to find the accelerate here, I must find the slope of the line in the first line. I want to find the slope of the first line. Here the slope is y2 minus y1 over x2 minus x1. It means 70 minus 10 over 30 minus 0. The slope of the 2 points, these 2 points, it will be 60 over 30 equal to meter per second square. 2 meter per second square. That's acceleration 1. Acceleration 2, for the second motion, it will be 0 because it's a uniform motion. No accelerate here. Accelerate of the stage 3 in example, it's a slope for these points 70 minus 0 over 90 minus 110. It will be negative 3.5. Okay, here I have a 3 accelerate of the 3 stages of the body. Number 2, I want to find the total distance which covered by the body. The total distance covered with the body. A first distance in a first motion, distance 1, v naught t plus half a t square equal v naught is 10 and time for a first stage is 30 seconds plus half accelerate in a first stage is 2 multiply time square is 30 power 2. It will be 1,200 meters. It's a first stage. Distance of the first stage. Stage number 2, it's a constant or uniform velocity. Then distance here is velocity multiplied by time. Velocity is 70 multiplied by time. At these points from 30 to 60 to 90, it will be 60. Then distance here is 4,200 meters. The last stage, distance covered in the last stage, but like a first one, v naught square, v naught t plus half at square. V naught is 10, v naught here is 70. Start the third motion. يبقى v naught is 70 multiplied by time is 20 seconds plus half multiply the accelerate here is negative 3.5 multiply by 20 square. It will be 700 meters. يبقى total distance distance of all the motion, it will be 1,200 plus 4,200 plus 700. It will be 6,100 meters. Okay, next, a ball fell vertically from a house window of height 2.5 meters. Fell, that's mean v naught equal to 0, and height here, the distance, it will be 2.5 meters. Okay, v naught equal to 0, and the distance is 2.5 meter from the ground. And at the same moment, a boy at a distance 13 meters from the base of the house move with uniform velocity in the direction of the house. Find the velocity of the boy need to catch the ball before reach to the ground. Here I have 2 motions, okay? Motion number 1, from the height of the house, 2.5 meter high, the ball fell down, okay? At the same moment, boy, about 30 meters from the base of the house, ran to catch the ball fall from the window, okay? What is the velocity of the boy to catch the ball before reach the ground? Here, firstly, I must to find the time to reach to the ball reach to the ground. I have S equal V naught T plus half A T square, half G. Here, dependent on gravity, it's a vertical motion. Distance is 2.5 V naught equal to 0, I can cancel it. Half multiply 9.8 multiply times square. Then times square, it will be 25 over 49. And time, make a root for this value, it will be 5 over 7. That's the time to reach to the pole, reach to the ground. Velocity of the boy must be come 13 meter in this time. What is the velocity needed? Then velocity equals the distance divided by time. Distance is 13 meter must be covered in 5 over 7 seconds. Then he must move by this velocity to catch the ball before reach to the ground. Okay. Next, the velocity curve of a particle is represented by a horizontal line segment. Here, velocity and time, velocity and time, and I have a horizontal line, like the example, previous example. Then, what about accelerate? Accelerate is equal to 0, or moving with a constant non-zero accelerate, or is at rest, or moving with deceleration. In the previous example here, here, the horizontal line means what? Means acceleration is 0. No acceleration here, because body moving with a uniform motion. Then no acceleration here. Then I will choose number A. Moving with 0 acceleration. Okay. Next one, a ball is projected vertically upward at its maximum height. Okay. At maximum height, what is right here? Speed is maximum? No, speed is vanished. In a maximum height, speed is vanished. Acceleration is 0, or acceleration equal 9.8 meter per second square downward, or acceleration equal 9.8 meter per second square to upward. Firstly, acceleration not equal to 0. Not equal to 0. Velocity equal to 0, yes, but acceleration not equal to 0 here. Okay, acceleration, it will be 9.8 meter per second square downward. When we moving vertically, accelerate is equal to gravity. Gravity not equal to 0 in this point, but gravity, it will be 9.8. 9.8. In which direction, downward or upward? Huh? Yes, it's downward, right? Because it's a maximum height, no up, it's a maximum one. Okay, a maximum one with respect to the body or the ball. Okay, then no up here. It must be 9.8 meter per second to downward. Okay, thank you for your listening. I hope it's useful for you. Goodbye.